Good afternoon. Last but I hope not least, I'm going to talk today about data meshes and metadata. Let me just introduce myself first. So, Ferd Scheepers, I'm the chief architect for ING. Been working for ING for a lot of years, and I'm very much into data and to metadata. And that's what we're going to talk about today. Let's talk with who is ING. Our stand for today, so if you have any questions later, please go over there. We're a bank. We're active in many countries, I think like 50-something countries. But I like to think about us as an engineering company at heart. We have a lot of engineers around the world. We build a lot of stuff ourselves. We're definitely not a bank that just has branches and everything. We're a digital-first bank, and we are recognized by Forbes as being one of the two most innovative banks in the world. I hope to be #1, to be honest, so let's work on that. Our engineers actually don't just build banking apps. We're also very active in open source. We build a lot of open source stuff. We have many contributors to open source and even committers on many of the projects, and that is also something we're going to talk about today. So, like I said, I've been working for ING for many years, and around 7 years ago, I started creating a new architecture for how we do data at ING. This is the picture of it. I'm not going to explain every box. At ING, we actually call it a picture with the many boxes. But if you look at what it actually does, it talks about how we bring data from A to B, from producers to consumers. And a very simplified view of that is actually this one. So we have systems that produce data. Normally it's a byproduct of the processes that we run, which is something we actually should change. And that data we bring into a data lake in a native format. So we ingest the data as it is, we historize it, and to make it easy for consumption, we map it to what we call the ING Esperanto. And that is really a set of business terms that we agree upon, so we have a very common definition of the most important things that we actually use in ING. I'll give you an example. When we started, in the Netherlands alone, we had roughly 25 different definitions of what a customer is. That makes it really hard if you, for example, want to answer the question, how many customers does a country have? Well, it depends on your definition. Well, shouldn't you then at least standardize your definition? So that is what we did. We started to standardize that definition, and we said that the moment you start introducing a connection between consumers and producers of data, you need to go via this common format, meaning that if you produce data, you just map it to the common format, you have one transformation to do, and the moment you want to consume data, it's the same story. You need to understand the ING Esperanto, your own format, and you're done. You don't care about who produces the data, you just are interested in what data do we have. And of course, on top of all of this, we have governance. We want to understand who uses the data. We're a bank, we have a lot of your personal data. We don't want everybody just to be able to use that, so we have a lot of strict governance on top of who can use the data, for which purpose, but also to understand where's the data going. And the moment we actually send data to our regulators, we actually need to prove to them that we know this whole process, what steps were taken, who touched the data, who made changes to it, all the processes. Now that sounds great, and actually it is great, but it's also a lot of work. So one of the things that we see is that it's a big challenge to put all that data into a canonical format. It is even a big challenge to actually standardize all those business terms, because you need to agree with a lot of people. So it becomes quite a manual effort to do all of this, and it's something that doesn't scale very well. And actually it becomes more complex as you start looking at the setup of ING, because, as I said, we're active in many countries, and that also means that our data, is created in Australia, in Turkey, in the Netherlands, in Germany. So we have many of these installations of our data lakes that actually need to talk to each other. And we need to ship data around, because the moment we start reporting to the European Central Bank, actually we need to have data from every country being brought together. We need to map it to things, and we need to send it over, meaning a lot of data needs to move around. And all of that stuff we're building, literally by hand. It's all ETL, it's all built, it's done, but it's a lot of work. And when you start looking at where we are heading these days, data, a lot of our data is still on private cloud. But more and more, we're also doing stuff in public cloud. We're moving data to Google, we're moving data to Azure. Again, all of that is manually crafted, right? There is no such solution as being able to easily shift your data around. You have to do it by hand. Now, looking at that, this is a challenge that is not unique to data. And when I told this story about a year ago at QCon, I was actually talking about flowers. And that's because my wife, who's on the picture here, she loves flowers. And when she came to the Netherlands, you know, we went to the Keukenhof. If you ever come to the Netherlands, go there, it's beautiful. And flowers are actually very, very similar to what we do with data. Because if you look at the process of actually moving flowers from producers to consumers, they are solving a logistical problem. I have these flowers, I need to understand what flowers I have to map them to a canonical format, because if I say something is a rose, you probably should agree it's a rose and not something else. So it is describing that in a common format. And also the whole process of bringing that data from the producers to the consumers, you know, has to go through a common infrastructure, which is the auction. The good thing what actually those logistical companies did is do a high level of automation of those processes. And in that sense, they're way ahead of what we try to do around data. If you look at these little cards as they're moving through the auction, all of that is driven by metadata. Every little box of flowers has a label. It's a microcode. It describes what's in there, who is the producer of that flower, what is the quality of the flower, you know, what is the length of the stem, what is the color. All these things are well described. And as these flowers are moving around, it's very similar to the challenge that we have to solve around data, because in essence what they're doing is exactly the same thing. They're taking their flowers, data, from all over the world, putting it in a central location, excuse me, deciding where this has to go to, and then from there transporting it to the consumer. All done, highly automated, but still challenging. That same problem that we have is how, in the best way, do I get from the producer to the consumer, but still in a rather complex way, because it has that central location. And in that central location, you know, everything gets decided. The good thing that they have is actually that the product actually moves together with the description of the product. So the metadata moves together with the data. And that's easily done because it's a physical thing, right? I mean, there is actually a way to put a label on the flowers and say, you know, this is the product that I have, this description of it, and I can use that metadata to move the product around, because it's a way to automate things. Now, when you look at data, there are many ways where you can do the same thing. And I always look at the JPEG format as a great example of data and metadata going hand in hand. If you take a picture on your phone, you don't only capture the image, the data, at the same time you also capture the metadata. So it will tell you exactly the format. It tells you where that picture was taken. If you have a professional camera, it tells you the lighting, all the conditions about that picture. And the fun thing is, the moment you actually send that picture to a different device, the metadata moves with it. In a perfect way, because the moment I make this picture here and I send it to my colleague over there and he has an Android phone, he'll be able to see not just the picture, the data, but also the metadata. They're interchangeable. They're understood on every device that you use, which is a great example. But for most of the data that we have in an organization, this doesn't apply, because there are no standard formats of saying data plus metadata. It doesn't exist. So in that sense, logistical companies, whether they send packages around or whether they actually transport flowers, they're way ahead of us. But they still have this one big logistical challenge, which is it all goes through a central location. And I actually have a really nice illustration of this. So imagine it's just Valentine's Day, and you know, the Americans want to buy flowers, roses, red roses. Where do you think those roses come from? Almost all the roses that are actually shipped to the US, they come from Amsterdam. 80% of all roses that are sold for Valentine's Day are flown in from Amsterdam. And where do they come from? They come from Kenya. Almost all the roses that are produced in Kenya are flown to Amsterdam. Now, isn't that completely stupid? So we actually produce roses in Kenya. We bring them to Amsterdam, so somebody can buy them, and then we ship them, or actually fly them across to the US. It's an insane process. And it's also something that you see that in the logistical industry is being solved. And if you look at today, this is a picture of a few years ago. Now, roughly 80% of all flowers that are created or grown in Kenya are shipped directly to consumers. They don't go via Amsterdam anymore. But in the auction, we still have the metadata that actually shows what we are selling. It's still being handled there, just the product doesn't physically ship anymore. And that's also the challenge that we're trying to solve with data. And for that, the concept of a data mesh was introduced. So for those who are interested in data meshes, read Zamak's book. It is really, really good. And it introduces the concepts of a mesh very, very well. It talks about why should we have this big central infrastructure if we can actually have different nodes where we have the data coming together in a very localized format, with local governance, with local descriptions, but still we need to tie it all together. It talks about autonomy of teams to create data, to describe their data products, as it's called. It's a really great concept. And it doesn't only describe about nodes, etc. It also describes about what is that you need to have in place to make this work. So on top of a physical infrastructure, as you would call it, a self-service data platform, you have governance decentralized. You have a lot of global governance as well, because there are still rules that apply to the whole organization, right? Like, for example, we're a bank. So we have rules around being able to prove that data actually followed a certain process. There are rules that actually are implemented or actually directed by governments. In Turkey, personal data cannot leave the country. That's a global rule. You have to apply that. You can't leave that to a local team. But you want to give that local team as much as possible autonomy on what they're doing. I love the concept. I think this has now been described a few years ago, and you see the whole world of data actually talking about this. Biggest challenge that I see, it's not a product, it's a concept. So if you go to a conference and they talk about data, everybody's telling you, do you want to buy my data mesh? And nobody has one. In reality, it doesn't exist. There is no product that fully implements an end-to-end data mesh as is described in the book. They give you parts of it. Yeah, I have a policy enforcement point. I have a catalog. I have this knowledge graph that can tell you everything about the data that you have. Do you have that full self-service platform? Do you have all those components? Do they work together? Do they link together? I'm sorry, nobody has it. If you just look at, I stole this slide from the internet. It is the vision of a company that is trying to implement a data mesh. And they want to do it across 2 different platforms. So they want to do it on AWS and on, I think this one is on Azure. If you just look at the number of components they actually need to integrate across 2 platforms just to make it work, it's huge. And if you want to implement this today, this is what you have to do. You have to integrate all these products because nobody is doing it for you. Now imagine a bank like ING. We want to do this. We want to do this also on a private cloud. We want to go to multiple clouds, public clouds. We have a lot of products that we have today, and we want to integrate all of that. That's a huge, huge challenge, and that's a huge engineering challenge, to be honest. So there is a fundamental choice if you like to embrace this concept today. It is about waiting to, somebody deliver a full product. You're going to have to wait a long time because it's completely not mature yet. You can completely build it yourself. That's another option, and a lot of companies are doing this. It's a lot of fun. I mean, it's a great engineering challenge, and give me 100 people, and I'd love to do it. But I think the real solution to that is, it is a question of collaborating with a few vendors and making it work. There's still a lot of engineering involved, and as ING, we're actually throwing quite some engineering capability at this. We can't do it alone, because the moment you've built a data mesh that works for you, you go to yet another product and you have to start all over again. You have to integrate it again. It's just a huge challenge, and something that, like I said, as a pure engineer, I'd love to do, but as a company, I don't have the money for. So one of the things that we're doing is actually working together with IBM to look at, can we create an open source data mesh product? So there's a product that we published on GitHub. It's called Fabric, and it is the implementation of a data mesh, fully open, which is for the moment very much focused on some of the challenges. It's not a full product. It doesn't do everything. It's very much focused on, can we describe policies? Can we describe automation of movement of data? Can we have policies that are actually like rules? Thou shalt not move public data or personal data across the boundaries of a country, but also optimization rules like use the cheapest place to actually store your data, use the cheapest place to actually process your data, and these are the prices that are associated with the compute that you have at a certain point in time. We have a number of ING engineers working on this. So if you go have a look there, two guys from my team, well, a guy and a girl from my team are actually contributing heavily there. It's a great product, but it's still definitely not finished. The biggest challenge that I see around all of this is actually this idea of interoperability, and then when it comes to metadata. So data, in essence, is simple, right? I mean, you can consume data through APIs. It works everywhere. You can have Kafka clusters or queues, etc. Every product out there can read Kafka queues. It's not that difficult. SQL, it's been around for like 1 million years, but every programmer can write SQL code, right? And every platform out there can work with SQL. It's simple, but what you get is bits and bytes. I just put years of effort into describing my data, and now I'm trying to consume the data and have bits and bytes. Now, I don't want to have bits and bytes. I want to have well-described data. I want to understand the semantics of what I'm looking at. I want to understand the data quality. I want to understand where the data came from. And I go back to my original challenge. I don't have anything where I can actually find a consistent way of describing that metadata. It literally does not exist. So several years ago, I'll just skip these because of time. Several years ago, we actually started looking at this challenge and said we actually need, next to a mesh for data, we need a mesh for metadata. Because we need to bring these things together. Same way as we want to exchange this data in an automated way across the different products, have it decentralized, have the governance done. We have to describe everything around that as well. And in essence, that means all those different tools where I maybe have my different domains describing the data in, they need to work together as well. So I need to be able not just to move the data around, but also move the metadata with the data around. So we implemented a solution together with a number of other vendors, and we called that Egeria, Open Metadata Standard. And what it in essence does is it implements 2 layers of APIs where you can standardize the metadata in such a way that all the different platforms out there that work with metadata can easily integrate. So we started this exercise with a number of vendors. So IBM was on board from day one. They've been a partner of ING for quite some years, so we had some leverage with them to actually, convince them to come on board. We managed to get SaaS on board, so a lot of the work we're now doing is integrating the whole SaaS tooling also with this product. We had Hortonworks on board, and that's where we started. So we built this out, and we actually have 2 levels of APIs that we built. So one is really describing what is it to interact with a number of repositories. So how can you share your metadata? How can you make your metadata available? How can you say, I have a business term, I have an asset? It describes a whole type system of metadata. Literally, we're close to 1,000 different metadata types that we have. It's very, very rich. We haven't encountered any repository that's got something we don't have in Egeria. And we did a lot of effort in integrating the IBM products, so IGC, now what's the knowledge catalog with this, the SaaS products, and I'll mention a few of the others later on. But this is working really well. On top of that, we actually created another layer which make it very easy to consume metadata. So we have specific sets of APIs that make it possible, for example, to do queries on metadata, distributed search. It could be a set of APIs that actually make it possible to show lineage across metadata, to do all these things. So it's a complex system of APIs, one's for integration and one's for consumption purposes. So we can actually start using the product, and it's now a very mature product. It's available on open source. It's built in a part of the Linux Foundation, and it actually offers 3 use cases that we use. So one is this metadata mesh. So it makes it possible to have different catalogs from different vendors connected to each other in a mesh setup. And it's literally built that way. It's got something that's called a cohort, which is a group of metadata repositories working together. That can be part of an overarching cohort, so you can create a mesh in every which way you want to. And this is a typical use case that we see where we actually want to have vendor products working together and exchanging metadata. So literally yesterday, I was in a call upstairs, and we were demonstrating the option to share metadata between IBM Watson Knowledge Catalog and Microsoft Purview, so the metadata repository of Azure. It changes metadata perfectly. You know, you create a business term in the one, and it just appears within like milliseconds in the other one. You map it to a physical asset, and that asset is now available across everything. You know, it's really a beautiful concept. So you have this one place where you can see all of your metadata. Second use case that we see, and that's typically used in situations where you want to build your own repository, or maybe there are products out there that don't have a very mature metadata repository themselves. You can actually use it as a metadata repository yourself, which is actually the third use case here. Apologies for that. So we have that now working. We built our own middleware within ING, and we are using Egeria as the repository for all the metadata around it. And actually, we now have a number of products out there that are also open source products that have embraced Egeria as their repository for metadata. So I think there's like 6 or 7 products that are now part of the Linux Foundation AI and Data that have embraced Egeria as their central metadata repository. The second one is actually those dedicated use cases that we want to visualize. So for example, we build a visualization for lineage, which actually uses the APIs that we build on top of Egeria to completely visualize the end-to-end lineage of system of records all the way to consumption. So if, for example, I create data in a system in the bank, it moves through multiple data lakes, it then gets reported in a Power BI tool, and that is sent to the regulators. All of that can be visualized in one simple visualization, which in essence is a graph technology. So rather than just promote this with vendors, what we are doing is actively contributing to this. So I've got a team of roughly 10 people building this. And they built this in open source. So literally everything we build is open source. There is not a single line of dedicated or proprietary ING code in there. If you go look at the Egeria site, and I'll send a link to you later for it, there is literally now 50-something people contributing to this. 10 of these are ING, but there's also people from IBM, there's people from SAS, there's people from Hortonworks, from Cloudera, there's people from Google now contributing, there's people from Microsoft contributing. We have a big audience now. And actually there is one large Swedish company who I don't think I'm allowed to mention by name, but they're very close to here, who will actually also start joining us as of probably next month. So I just had a conversation with them last week, and they're very eager to join. They've already joined our conferences, so hopefully soon we can identify their name as well. So this is my team that's building it. As you can see, we have quite a diverse team, and most of them are, well, actually there's not a single Dutch person in there. It's mostly Romania and Poland and Moldova and Montenegro and Ukraine as well. it's a fun team. They have been involved with this from day one, and one of the reasons to be here is because we do these kinds of developments, and we are definitely still looking for more people to join us. And what I've seen is it is really fun for people to actually contribute to open source. I mean, it's very different from what the rest of ING is doing, because most of our engineers, they just build dedicated applications for the bank, and we're building open source. And also in the governance, that is quite unique, because normally you have a business partner in the bank, and he tells you, I need to have this done. And you're just building exactly what they want, well, hopefully with some steering to make sure that they completely come up with stupid ideas. But this is purely driven from open source. So my engineers are working on what comes from the community. And that's a really interesting model in ING, because I have people knocking on my door and they say, hey, Ferd, can you build me this dedicated screen because I need it? And I say, well, put it on the backlog. Yeah, but these are ING people. I say, yeah, but they're contributing to open source. Put it on the backlog. But how do you prioritize? Well, I don't prioritize because, it is an open source project, so, you put it on there, and if people in a meritocracy think it's a good idea, we'll pick it up. That's a challenge in any company, and especially, this is new to us. We do this in some places, and it's really hard to keep this Chinese walls between, the focus of a company that wants to have something done, and, being a true contributor to open source, because you don't want to be side-steered from anything, right? But that's my challenge to solve, and until now that's going quite well. So what are we doing with this inside ING? So our first use case that we have is actually the search capabilities. So we have a lot of tools with metadata, and we really want to be able to find everything. So this is the first one we have, be able to find where things are. So I'm looking for customer data. Do I know where customer data is? Well, you might think so, but actually I have multiple repositories, so there's multiple places where this actually governs. With Egeria, we can find it across the board. So I can search for customer. It will tell me every business term that has customer in there. It will tell me everything that's related to customer. It will tell me every asset in the bank that actually is implementing the definition of customer. And that works at the moment across all the databases we have in the bank, our data lakes, our data warehouses, our APIs. That's also a cool one, because that's also something that's really, really badly governed in most organizations. Maybe the data is governed, but APIs. Topics on Kafka, same. We implemented a mapping of what is on our topics towards the canonical description that we have in our ING Esperanto. So the moment we're looking for customer data, we also see which topics they're on. And this goes end-to-end. So we can also see where is this customer data then used, all in one query that just ranks it. You can select, you can say, I just want to see business terms, I just want to see assets, I only want to see something on Kafka, I only want to see it on databases. All of that stuff is available, which gives us a lot of insight. Because all of a sudden we see things that we never thought that we had. Because it's all being brought together now. So the next use case we're working on very hard is show the end-to-end lineage. And this is a big one, because we're a bank and we have a lot of rules on top of what we normally need to do. I think banks are probably maybe next to the the medicine industry, the pharma. We are the most heavily regulated industry in the world. And our regulators tell us, you have to prove to us that the data you're showing us is true. Show me the lineage. Well, it's not literally what they say. They say, show me that you're doing the right thing. And we've translated that into show us the lineage. And there's this beautiful guideline on banks. It's called BCBS 239. And it's a monster. It really tells the banks, you have to show end-to-end exactly everything you're doing. We're very comfortable with that, because we say, have a look, here it is, lineage, end-to-end. I can prove you that the data I'm sending to you is this. It's not documentation, it is actually what is happening in the bank. Actually, this was my main selling point for doing this in ING, because a lot of banks who did this, they entered all that stuff in Excel. They literally spent, in some banks, millions of man-hours on just documentation. And the moment you're finished, you're already outdated because everybody knows documentation is never keeping up with the reality, right? We don't have documentation, we have reality. What I'm showing to the regulator is real. This is a fundamental one, and this is probably, for me, the most important use case of all of them. I know where my data is going. I know who is using my data. So, like I said, this is all real. This is all open source. This is something everybody can use. So we made a very conscious decision as ING not to build this ourselves, to build this with vendors and to make it open source. Because I don't want this to be a competitive advantage. I want this to be something that all vendors adopt because it will give me advantages. But I'd actually also like other companies to say the same things to the vendors because it puts pressure on them. And if vendors actually start adopting this, maybe other companies will be interested, like this Swedish company I won't mention, because they now see that it's reality. They start being interesting, and they start putting pressure on Microsoft to do this integration. So that's why I'd like everybody just to have a look at this, and where possible, adopt it or contribute to it. It's a very open community. You can contribute. You don't even have to become a member of the Linux Foundation to actually join. All the code is free. We have a lot of tutorials there now. A few years ago, that was really hard to adopt. But now it's literally, it's a set of containers. You can deploy it. There are use cases. There are Jupyter notebooks to start demonstrating how this works. It's really very nice to consume it. You can have it up and running in hours. So that's my call out to all of you. If you're interested, have a look at this. If you want to join us. If you actually want to come work for ING, which is one of the reasons we're standing there, we are more than interested to have that conversation with you. Yeah, join us in making this successful. I honestly feel this is a fundamental thing that's missing in the community out there, a standard for metadata. We think we have a really good standard. We think it's something that's worthwhile investing in. And we do, because I've literally spent 7 years of investing in this, and I have 10 plus people working on this, so it's also a big financial investment from ING on this. It's given us value. I hope it's giving more people value in the near future. And with that, I'll go to questions.
Thank you so much for the talk. So we have one question here, and then I'll turn it over to the audience.
Sure.
What about data ownership? Data producers are usually not interested in owning or doing much with their data. Seems more like a cultural issue than a tech one. What's your take?
It is. Data ownership is a really cool one. So who owns data, right? Is it the person that owns a system of record? No, probably there is like a business owner behind it that actually owns that data. And one of the beautiful things that actually comes with the concept of the metadata is the idea of data products. And the next step with that is actually data monetization. So it's something that's a little bit of a dirty word at ING, so I'm a little bit hesitant to use it because people really start translating it immediately to, oh, should I now pay for the data? Well, why not? If that data is valuable, then actually the owner of the data should see it as a product he's contributing to the organization. I mean, we're a bank, so we do payments. Payments, especially these days, is a loss-making business. You can't make money on payments. But the data coming from payments is very valuable. So why not actually pay the data owner for the usage of that data? Make it a real product. I mean, with a product comes also, you're willing to pay the price for it. And maybe then actually the data product comes the primary product of that business, rather than, yeah, I'm doing payments and with that also comes some interesting data. No, why isn't that the primary result of your business? And if you think that way, shouldn't you then try to capture much, much more payments volume just to get your hands on that data, which is in essence a lot of what fintechs are doing, right? They're offering a lot of these services for free. Why? Data. But we're kind of hesitant to think that way. We all think, no, we do payments because we want to make money from payments, which we're not. And the side product is data. I think data ownership becomes really interesting the moment you are valuing the data also as something that has a monetary value. And I think that's a fundamental cultural change that we have to have. It's not a side product. The whole idea, if you read Zamak's book, is it is the product, right? That's why it's called a data product and not a data byproduct.
Thank you.
I saw a question here as well, yeah.
I think you already partially answered my question. So my question was also, how do you motivate people to provide the metadata to your platform?
That's a good one. So the question was, how do you motivate people to bring the metadata to your platform? So partly, again, it's that cultural challenge, right? If I have data and I want you to consume my data, I need to make it interesting for you to consume that data, right? So I package it, I give it a nice name, I describe it well, I give you the information about the quality, etc. That's the perfect way to drive it, but that has to come with kind of like a kickback, right? I give you my data and I describe it well, and in return of that, you pay me something for that data, whatever it may be. We're not there yet, so that's where we want to go. But in reality, at this moment, it's much more about thou shalt, right? You have data. We need that data, for example, for our reporting to the regulators. You must put the data in our central environment. You must describe it. And there is a regulatory reason, so it's kind of like a little kick. You have to do it. But the other way would be much more powerful.
Right. Do we have any other questions from the audience? Okay, another one.
Have you looked at the LinkedIn Data Hub? Because I think they are doing something very similar to what you have there.
Sorry, which one?
Do you know LinkedIn Data Hub?
Yes.
They also have a very similar solution as you have. What are the main differences between both solutions?
So what we have, I think from a pure technology perspective, is much more comprehensive and has a much more broader use case. So this one is very focused and it has a specific use case, and it actually doesn't have a very rich type system around data or metadata. Ours is much more rich. And actually there's like 2 other competing products out there. They're both called open metadata. So one open meta-data and the other one open metadata. What they have better than Nigeria, in all honesty, is they spend a lot of time on making really, really cool GUIs. You know, it looks nice. Under the hood, there is nothing. That's a little bit the problem that they have. But it looks really cool. So there are some competitors out there. We started more than 5 years ago. We have a very rich system. And we've shown we can integrate, because we literally at this moment integrate with SaaS, we integrate with Microsoft, we have basic integration with Google, even though we still have to work on a bit. We're doing integrations now with Oracle. IBM is working very well. If I have those, and maybe I need to get my hands on Informatica and Collibra as well, I'm done, right? I've captured 90% of the data world and I can integrate with everybody. Next year, I'll have those as well.
Very good. So in the absence of no questions, I'd like to say thank you very much, Ferd, for the talk. If you have more questions or if you would like to learn more, that's the booth.
Indeed.
You're welcome to join them. So please let's give it up for him. Thank you very much. And